measuring tape, as Claire has right here. And we're gonna lay it down and we're gonna figure out, so between all of us, we have to make it reproducible. We have to figure out how long we're gonna make the transect to get the best sample size. We have to figure out like how far out are we going to look. What we're doing is we're gonna be looking for a deer scat, and we're going to guess the population based on the deer scat. And our deer scat is going to be proved.
So if I have like kiddos, like what would they need to know ahead of time to be able to even have a guess to like what distance that should be?
So it really kind of depends on where you're working. Like working on a bigger open area, it really depends. I mean, you could even do like 10 feet, a few 10 feet in different locations, so you can get different areas. I mean, we chose an area originally over here because there's a bunch of different deer scat. We saw some like really different ones. Choose somewhere maybe under a tree or where there's shrubbery that an animal could actually be scatting, so that they can also have a better.
Well, that goes into bias too.
Yeah.
So we have to figure out, because bias is like the number one thing. So how do we get an accurate population if we're gonna pick something underneath the tree, because that's where they're gonna hang out the most, you know? So that's something that you can bring up to your students. But as Claire said, she brought up a really good point that it depends on the size. So what's gonna be a decent sample size for the area that you are studying? Are we just gonna focus on this one little area over here and just say, okay, we're gonna do the southwest side, and then that's going to be our study area? Or are we going to try and take the entire population to the entire refuge, which is a lot of acres? I mean, our transects will have to be really large, and is that feasible? That's another question that you can ask. Well, if we do 200-meter transect, is that feasible? Are we going to have enough time? Are we going to have enough resources? Like, these are all things that you can bring up, and I mean, there's no right or wrong question, honestly. It's just what you think is going to be the right answer.
Which I think is definitely the hardest.
Yeah.
Parts of like within these methodologies is that you really need to ask the biases. Like if you're mapping stuff, you need to ask the bias of if you're going to map a population of people, are you focusing more on one group of people in a certain rich area versus a lower income area? How's that going to affect the data? Is it actually going to represent the population as a whole within what you're looking at? So when you're doing it, you're definitely asking yourself these questions, and that's why we're just gonna throw you into it a little. So like when you're doing it, then we'll have like little discussion of like answering some of these and what you think was reasonable based off of, you're going to choose a length, and then how do you measure
do you
poop?
think, yeah, and then we'll have
side?
a discussion about it. Is this okay? Is this, how do you think that you guys did? We're kind of like, we're directing you, but you guys are going to be doing the activities.
If I was just a kid and they're looking at it, it's like, if you're making transects, where are you looking at the poop? Is it right next to the transects? Are you looking at the poop if you're like here in the transects right here and you see one over there? Are you counting that? Is that like being biased towards it? Is it out of your data zone? You need to stay within the data zone.
So to some extent the data kind of tells you what your size is, because you don't want to have it's 1 and then 2 and then 1 and then 3. You
Right.
want to have big enough numbers, so you may have, you know, different sizes to get enough, so it's not just 1 and 2 and 1.
Exactly.
So,
And of course,
One group is going to do transect, and then the other group is going to do transect, and then we'll come together and we'll discuss about how each of the groups did.
and that just comes down to like the biases too, of if you're working with a group,
Right.
people's eyesight when working with at least bison, it's like, oh, that's medium, and someone's like, that's large.
Yeah.
So you really need to
Gotta be on the same
define
page.
define your terms, define what you're looking for. And what I was telling Kay is transects, you can have multiple ones, and then you normally put flags up. And so when you're walking down, you'll discuss, do you want to just look on the right side, the left side? So it's kind of hard to visualize with one, but you're making your own method right now.
Do you like? I just
I mean, as you said, if they poop 7 times, only one poops 7 times. And if there's more than 7, then there's a likelihood that there's more than one animal out there.
We didn't start with that. How many animals are out here? That's good.
and
That's good.
And then, so I guess the next thing I would say is, so you're taking your data, what is it, every 3 feet or every 5 feet? You see how many there are every 5 feet, mark it down, the next 5 feet, the next 5.
Right,
Maybe
so-
5 feet might be the right amount, I don't know. So maybe we just stroll it down, look at it, observe it, then we decide, oh, this is how we're gonna do it. Then we go back and start methodically doing
Let's
it.
do it.
Approved and poops or simulated poops?
I don't know. I mean, I think the simulated poops might
Okay.
be a little easier to pick out than tall grass.
Okay, sorry.
We won't
But
miss
if you
them.
want to do,
That's fine.
Good eye, yeah. Those aren't
I was like, those are real poops.
Those don't taste like food.
okay, so I'll do like 1, 2, 3, 4, 5.
So,
five
so I
pieces.
put like 8 and then like 1. So then we need like 8 pieces in one pile.
Okay.
Hence why the one is actually like a lot bigger than the other
Okay.
individual ones. So like we're doing all the data on this side and they're doing all the data on that side, and then
So-
we'll get together and
So I think
Would you
this
put
is
it all
ours,
together,
right?
or would you keep it separate so that way you have more data points?
Well, it's starting separately, so it's fine. We can combine it. I think this is ours, maybe.
Yeah.
So that's right there. Oh, it's right at the 15 feet.
Okay.
But are we also thinking that like when a deer does like go to the bathroom, like it's usually not just like one little piece, it usually is like a pile, and so then like any runoff, like any little pieces come from that pile and have just
We
like
got
spread
7.
out.
This white-tailed deer versus mule deer. I don't know how much they look different.
I don't know either. I think that's genetic testing you gotta do with that.
I actually think it's like bears. A black bear's scat here is gonna look way different than a bear's black bear up in Alaska scat.
Right, that's
Their
very true.
vegetation's a lot different. They're eating probably a little bit more meat than they are here.
But I mean, if we're talking about 2 different species of deer within the arsenal that have all the same types of,
Oh, I was just thinking size. Like, you might be able to tell just by the size.
right?
Is it each individual poop, or is it just like? Because some of it was like there'd be like 1 or 2, and then there'd be like a big clump. So we decided that at that point that we would just put it all together as one, even though it may mean that multiple deer were there that did it, but we just counted it as one. Probably the biggest question was really how far out were we going to go as far as collecting data. You know, that was really the biggest one. 'Cause, I mean, you could honestly go, you know, fingertip to fingertip and then you're scanning, but then, you know, are you really going to collect everything that you see? Especially with actual deer scat. I mean, it's small and it blends in really well. So the prunes were actually helpful because they did stand out a little bit more.
Ensure that your data, there's quality behind it. And it's not just like, oh, you guys did great, you collected data. Well, you don't know what you collected because everyone had a different idea of what was going on. So I think just getting everybody on the same page with like, okay, we did 50 feet as well. And we did about 2 feet off each side. I like your rationale behind that. It's about your, you know, it's like your field of view, your kind of your swath path. So if you have like a big group of students, you know, you can cover quite a bit of ground. You're like, you know, everybody arm width apart and just kind of go out. And it's hard to see small stuff, but I think when you're working with a manageable distance, like 50 feet, I think just not biting off too much is like the biggest problem. You know, so that the kids aren't like, I don't know, how are we ever gonna do this? Like, that's a manageable distance. You have like, it's your pathway. So I think that was a big one, just making sure that the kids are all on the same page and it's manageable to them.
Like the question Lexi asked us, well, how many would you do? And then that always comes back to, what's your question?
Yeah.
Exactly.
So,
We were talking about like extrapolating, like, okay, do we need a cluster as 1, or should we count 12, and then would we have to know like 12 equals 1 deer, like if you're trying to figure out the population?
Right.
That's what we were kind of like.
So that's where background research also comes into play. But like they started counting every single individual piece of pellets, and I was like, are you looking at how much
Like a
biomass they're eating, or are you just looking at population? And he said if 1 deer makes 7 piles, then that's how many piles you'll be looking for. So it all depends on your research question. You want to get in there. I mean, you have one summer to get all your research done. For kids, you only have a couple of weeks to do research with the kids before their science fair is up. So how much time do you want to spend collecting other data when you should be collecting the data that's reasonable for your question?
How approximate we're looking exactly.
Right.
In this work, we're thinking about, not just like a pipeline for scientists, right? But like engagement in research, teamwork for all students, development of 21st century skills. And so all coming to consensus, right? Oh, that's huge. I don't care what you're gonna do, right? The teamwork piece, like, so those are really beneficial things. And then also, why do they care about this? Like, what have you done to generate interest and relevance for the students that they're like, oh, I want to count poop,
Yeah.
right? Because
You can get some videos.
there's not a fixed order to, like, maybe you're doing like pure exploration first and then you set things up, or there's not one right order. You can do things in different order and kind of mix it up and see what works for your kids.
And that's what's so much better than homework
Yes.
compared to doing this. Because when you're outside,
Yes.
I don't think that we're really taught to collaborate
Yeah.
in doing our homework. It's like you're cheating if you ever
Right.
get collaboration to finish your stuff. And it's like out here, you guys need to
Have
constantly
to.
find the
Right,
best
right.
forms of communication, the best forms of how to do things. And you're not the smartest person in anything. No one really is. But there's other people around who
Right.
can help you and give you that new guidance. So definitely teaching them in this process, it's not cheating to collaborate. I find that is like one of the hard things with students is they're like, I'm scared to ask. And sometimes you get too focused in yourself. So it's like, it's okay to ask.
Randomly estimate the percent cover of vegetation in 100 randomly placed quadrats. To randomize, throw the quadrat in a random direction 100 times. But with the quadrats that we have, they're a little floppy. So we're gonna have to figure out as a group how to tweak it a little bit to kind of work with what we have.
It's going to be like percentages of how biodiverse and how rich do you think your grass is based off of, for example, like 0%, 10%, 100%, whatever. So there's going to be a bias of if someone's throwing it somewhere. So we're going to try to cut down on that bias.
Right.
And by doing that, there's one great example Lexi had of trying to cut down on that bias of where you're going to be throwing it.
For the next activity, we're doing something also with grass, and we already have like a game plan for that, how that's gonna run. So this one's gonna be all you guys trying to figure out how you're gonna do this experiment, and then for the next activity that we're going to do, we're just gonna give you all the methods. And then for our last activity that we're doing today, we're just gonna give you all the tools, and you can come ask us questions, but we're not gonna tell you anything. So this is how we're gonna progress a little bit to get you guys thinking a little outside of the box and how you think the experiment should be run in your own way. So for this one, we're just gonna get into two groups, and we're gonna go 1, 2, 1, 2 to eliminate any bias. So we got 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. You're not in it. Are you gonna participate? Okay, gotcha.
So it'll be one.
I'll be number 2.
Do you guys want to be here, or do you guys want to move if you saw a different place that you want to be throwing that, of getting that data?
Start here.
Yeah, I was gonna say if we could start here and then maybe go over to where we were doing the bird stuff, because there were like some random like barren patches over there, so it might be a little bit more of a better representation of some not quite as high percent areas.
So would this be something that you would do like in like a straight line? Like even though you're having these, you take it and you just like be like, okay, plot my points and then go down.
We either have 3 people throwing the quads and 2 people riding, or we can have 3 people riding and 2 people throwing quads. Who wants to do what? Because first we got to do that, because that depends on if I make another flag.
I can write. I don't want to write.
I was almost say 2 people throw and 3 people write. Yeah.
Yeah, so she's a writer.
I can write.
You want to write? So you 3 want to throw? So I'm going to make one more of those guys. And then I'm going to grab you a... I know, it's flimsy, but we're going to talk about how to get over that flimsy.
Get it.
This one is definitely a low percent. And also it just looks like more because like we're focusing on like the top.
Yeah.
You know, like when it comes down to the root, like it's actually not making up that much percentage of the total space.
Yeah, right. Like this, I would say.
I'm so bad at estimating, I don't know.
Well, and also there's quadrats that actually give you sections, like a square inch section inside of it, and it gives you a lot better of an idea of
So you
how
could
to
count.
yeah.
If we had the time, we could truly like count how many.
Right.
But what did you guys
So what I might do-
estimate of the percentage of
I might do
this?
is go like this. Like I said, I'm kind of a math guy, so
Yeah.
I'd say like
You
okay,
take
this,
over.
this will be like 50%. I mean, that still doesn't look like it's more than half covered. Where,
Right.
So I think of it as like, okay, this one is still, even at 25%, it's not even barely covered there.
Yeah.
There's really nothing here.
Like 25 on this side.
I can't imagine it being more than 25 on the whole.
Yeah.
that's what I'm
I would
thinking.
probably say about 30 to 40%, maybe. Probably closer to 30%.
You can go 30.
33.
And a third.
When we were doing this, you guys are going to put down the percentage of what you think. You thought it was 45.
Yeah.
And then once you do that, when you get down here, you're going to be like cutting them, and you're going to have these bags, which I'll give to you, since you're going to be part of them. And then your Sharpies. So it's really up to you on how you decide you want to do it. This looks more of like a different one than just a grass.
Right.
So do you want to only be cutting grass if you guys get it or not?
Make sure we get everything in there.
Yeah. So are you cutting from the roots, or are you?
No, like pretty much flush with the ground,
Okay.
or a little bit higher than the ground.
Right. Just whenever somebody else has to do it, they have to know how they're going to do it.
Yeah.
Did anybody say what the maps at the back
It was 0. Does anybody know why we would do sampling like this, or what the point of collecting and finding the dry weight and the nutritive content of it is?
It's kind of like how healthy you can start to get an idea of like the soil, how much it's retaining moisture-wise. You can see.
Well, soil moisture and plant moisture are completely different.
Right.
Okay.
Now are
But
you
being
ready
a
to
plant
do it?
able to
X
achieve
that.
from the its surroundings.
Right.
No.
So I
Still
mean,
got a
we
couple
have what kind of animals out here? Mostly what?
Deer and bison.
Which are all
Grazers.
Grazers. So we care about the nutritive content because there's a bunch of grazers that live out here that eat the grass out here. So especially it being a closed system, we need to know how much nutrients there are for the herd of bison that we have on top of the deer population that we have. So that way we know that it's still a viable system and nothing would be degraded from having too many bison. Because if we have too many bison and not enough grass, then that could have really detrimental outcomes to the ecosystem.
And the water, they get some of their water from that. So that's the difference between the
Right.
wet and dry is almost like drinking water.
Exactly.
They eat.
Like I said.
what can we do differently as educators to better engage students, open up those pathways, help make it relevant, help make it accessible, help get them excited. So all of this stuff that we're thinking about it, like that's really a tool that you can use is how might, you know the kids are like, yeah, and they're super excited. They're already on board, but like how do you get the kids that want to go hide in the bathroom? If you can get those kids on board, you're really getting everybody. And so that's why we find the focal student kind of lens to be a really helpful tool in this work, because it's kind of a means of scooping up all your kids.
The outdoor education, I think, really makes a
Yes.
difference.
Oh,
Because
yeah.
a lot of times I think of vocal students that in a traditional classroom really have challenges or have avoidance issues. You take them outside and their perspective changes a lot, and you give them a why or a purpose or a meaningful activity, then that's the
They're into it.
Yeah.
Finding natural science that is still relevant and prevalent, in the urban settings that they're overlooking to engage them. And I'll be like, oh yeah, all about these mountains. I'm like, yeah, I've never been there.
Yeah, well, it's like you
You
don't
know?
care about a place until you see a place. And for some of them, like
100%.
it's the street, or they haven't been outside of Denver, and so it's like you show them the place they live in, they might connect with it more.
Yeah, I probably was a focal student when it comes to science when I was young. So in group work, I'm the fun person in the group, but I'm trying to get with some people that are going to do the science work. Yes. And so when we were outside, and they was like, "Y'all want to change groups?" It's like, no, because I feel like I had the best little setup. But we changed groups so many times, and like what you were saying, having people actually needing and looking at me and deferring to what I thought. That was good. I'm like, okay. I'm still in the group. Yeah. I'm a meaningful part of the group.
Yeah.
And so that's how that's important on engagement.
And the hands-on nature of the math, right? Like that makes such a big difference. What units are you using? Oh my gosh, I don't know. I gotta look and confirm and write that down, and like they're not gonna forget that.
Well, and it's so fun once you just introduce the component of, well, have you measured that? Have you looked at the change of that? Oh, I need my ruler. I need that in my bin. I've got, no, we're using metric. No, we're using Celsius. We're scientists. It's so cool to see these little guys really engage right up to that and take that on and find that application to that. It's really awesome.
And you all, as our facilitators, have been great with probing questions. You just keep asking questions and not giving away any information. You're challenging our thinking to push us to figure things out.
I heard so many students this year that were just like, I am really proud that I did well because I don't get science. Like, I don't do science. Or like, I was watching a student do math and she's like, I'm so bad at this. I was like, well, if you knew it, you wouldn't be here. Like, if you could do it already, like, what would be the point? It's just practice. Like, it's just practice. So like, going outside, I think, gives the sense of like real practice. But that is, if you're like not teaching yet, it's totally real. And I hear it all the time. It's like, whoa.
I'm not a math person. Oh, that's funny because you're doing math.
Yeah, right. I'm like, that's weird.
I don't get science, but I know that the sun turns everything green. Oh,
Yeah.
You are a scientist. You understand photosynthesis. So
Yeah. Or
you
even
not
in
know the
labs.
actual word.
Yeah, labs. Well, what do we do? I don't know. You're the scientist. You tell me. Like, how are you going to set that up? And they're like, oh, yeah.
I always tell my own personal kids, it's like, you may not be that, but you're a problem solver. Don't be a problem creator, be a problem solver. And they're like, oh, okay, well, let's see, if this was my problem, this is how I would fix it. Okay, you're doing it, you're not classifying yourself as that, you're trying to solve a problem.
Well, let's get out there in nature.
All right.
Woo!
Well, first get into some cars. Logger, or I call it a hobo, so I put this here yesterday, so it should be collecting temperature data for the whole day. So it's useful when we take a temperature measurement, it's just one time of the day. This thing will show how the temperature changes during the day. So I'm just putting it here, and assume nobody's finding it and it's in the shade. I always want to keep it in the shade for temperature. What time of the day? It's 24 hours. What's the start and end? Can you tell? Guess the starting point, the ending point?
How is it 104?
You know that's the morning?
Yeah, there's no time stamp.
So what's the start time on here? Do you think?
The hottest.
Close to noon. Probably.
So like 2
Most of the
o'clock,
the
3
hottest part of the
o'clock?
day.
2, 3 o'clock in the
Or it's the afternoon. Yeah.
Right, but it started before the peak, so it's a little bit before the peak,
Okay, so
right?
around noon.
Close to noon.
Noon, Mountain Daylight Time is exactly right.
Yes.
That's
You took weather and climate.
No.
Oh, I just took
for
it.
a meteorologist. That's 18Z because it's Greenwich Mean Time or Zulu time. It's 18Z. So we just it's UTC is Universal Time Coordinate. It's right, UTC. So
did you not put anything on the x-axis intentionally?
Like that.
So, but you should, right?
Right.
So what's missing? You should put something on the axis. Plus, I'm lazy because it would have taken to
10
put in that
seconds.
stuff and
Okay.
so I think
What is Hobo 60?
oh that's
It's the unit.
That's the thing I saw down there.
yeah. Well, you saw another one. I don't know which one. This one, the number here is 2104 8060.
Like not missing
See, I first when I saw the front of that, I was like,
they really.
I was like, is
Oh,
that
yeah.
like a film thing?
what it does.
Yeah.
So this one's pretty simple. It's just temperature. One thing on there. Why does it go up and down? And what's the hottest temperature on there?
104, 105.
104, right? Is it actually get that hot out here?
Yeah.
The official high temperature yesterday was 89, believe it or not. The day before that was like 92.
I beg to differ.
For a big area.
And that's at
Yeah, brace.
3 meters and not in the sun. So is that one in the sun or in the shade?
Both.
In the shade, kind of, but if you look at it right now, there's a little sun coming through. And so that's one thing to always think about with temperatures is always measured in the shade. So when you're measuring a temperature, a regular thermometer is gonna say it's really hot if you have it in the sun. So you always have to try to find someplace. Think about what we were doing with the last 2 days, really coming up with our own protocols. And those are the protocols that you are going to do so it's reproducible, right? So I think it's good to come up with your own things. What is the consistency? You can always go back if you want to enter your data into some database, then you have to make sure you're consistent. If you're doing a single research project, you can do that protocol. Any comments on protocols? Any of you all? Maybe you don't think of them as protocols, but that's what you're doing when you're coming up with a method, right? A consistent method.
So the one you just took from over there was 2 meters?
No, that was not an official thing. I just put it. So this I could put it anywhere. I can put it in the water, although I don't recommend it. They would laugh at me because I lost some in the water. So.
Oh no.
Or you have to, or I forget where I put them.
Yeah.
So I think,
Sounds like me. I love that.
like where was that piece of paper that had down where I put it?
Yeah, Don must have not given it to me.
So, but that's the right question. Is this official, and can this go into that database? So that's one of the barriers, kind of, with Globe and doing those protocols that we won't worry too much about today. But the other thing I wanted to talk about is cycles and spheres. So the spheres in Globe, it's divided into spheres. It's the atmosphere, and today I'm Dr. Atmosphere. We have the hydrosphere, the water. We have the soil, the geology, we have, what else, what am I missing? The biosphere. And then we've kind of got into the Earth as a system. How do all of those things work together? So think about temperature. How does temperature work? All comes back to the sun. Maybe a very important thing, kind of an extra add-on, complementary with whatever you're doing. So when we're looking at the prairie dogs, that's useful information to be writing down. What is the temperature? What's the time? What's the, things like that. But you could think of whole projects related directly to how do I tie temperature to something else. Maybe a very important thing, kind of an extra add-on, complementary with whatever you're doing. So when we're looking at the prairie dogs, that's useful information to be writing down. What is the temperature? What's the time? What's the, things like that. But you could think of whole projects related directly to how do I tie temperature to something else. Your temperature is going to be all over the place, depending on exactly what the surface is you're looking at. And so ideally you do it in 9 spots, 5 meters apart, and you get an average. And one of the things they like to do that with Globe, because they compare the ground data with a pixel from the satellite. And so when we did things with soil moisture and things like that, they didn't even want our urban data. They just wanted someplace out like this, that a big kind of homogeneous area.
We're doing things in a consistent manner that it makes it meaningful. And then we're also able to A/B digital versus analog. So if that thing's battery runs out, oh my God, what are we gonna do? Well, we still have these. Maybe it's not quite as accurate when we get 72.5, and that's like 72, 73, it's, you sacrifice a little bit, but it's just so that, the students know what is out there and what, how we've been able to take temperatures and what that means. So yeah, surface, subsurface. And then real quick, just because I'm a geology guy, Colorado's #1 geologic hazard is expansive soils. So foundation problems, roadways, infrastructure, all of that stuff. It's a huge issue in Colorado. I worked for a civil engineering firm for a while, so I didn't realize how big of a problem that was. Some clays can expand up to 20%. So you see those roadways that look like roller coasters. It just wasn't properly treated. We have a lot of expansive soil here, clay, and so that in the classroom it would be cool to do it on a smaller level, as if you were to be able to build some sort of foundation or roadway, saturate it, have it completely dry, and then saturate it, see the expansion. So those are other types of things. When you come into contact with this, it obviously has some clay because it can hold a structure to it. Now as we move away, we'll do this again and see, does it have more sand? If it's got more sand, it's not going to hold that structure, right?
If you were doing an experiment, how would you set that up? I mean, would you try to take the temperature at the at different depths? Would you do it different times of the day?
It also depends on the research question. So if we were doing something with a fish, like the fish spawning, and they only care about the inner banks and the temperature of the inner banks where the fish go to lay their eggs, then I would stick to just the outer banks of it, where the fish would be. But if I'm doing something where I'm trying to take the overall temperature of the creek, then yes, I would do some from the inner banks, I would do some in the middle, and then I would probably go down every 100 meters or so and just do upstream versus downstream and stuff like that. And then if there's beaver dams too, so if we find a beaver dam, you could do upstream versus downstream. So it's definitely variable on the question.
And so what's the difference going to be with standing water versus moving water?
Yeah.
How does that going to affect the temperature?
Oh, right. Moving
how
water.
About a big lake that's deep versus a shallow lake? How is that going to be different?
Right. Exactly. So depending on the question, if it was something like, if it is about how deep it is, then yes, we would have to go in and go to the bottom of the lake and try and figure out how cool it is or how warm it is down there.
I think it leads to like an interesting conversation about like thermal pollution, like having excess heat in the water.
Right.
Because like when we first started taking temperatures of the water, I was just kind of like, why? Because it wasn't until like I started doing like background research where I was like, okay, like the temperature of the water, even if it changes a couple degrees, really matters to the dissolved oxygen, which affects the life living there.
Exactly.
And it was really interesting.
Cooler water means that there's more
about
dissolved oxygen, meaning that there's more life and more. And then you could always take macroinvertebrates, which will also confirm all of that as well.
For sure. And then like just thinking about the different causes of thermal pollution, like urbanization, not having that impervious surface that like doesn't absorb the water like it should. Power plants, I know there's been like laws put into place where power plants have to cool down their water now before they put it back in the environment because it was affecting the life that was living there.
Because they're very sensitive to all of that.
Yeah.
Just a slight change of temperature, and this goes back to the ocean.
The black-footed ferrets, black-tailed prairie dog out here is their main food source. So that's, I think we're super lucky just to be able to come out here and witness that cycle. Studies also indicate the prairie dogs actually increase species diversity and protein content in the grasses. And that's something I had never heard until this lecture. So that's super cool. They're very social animals. They live in groups in prairie dog towns or colonies. Towns are complex. They burrow underground and they have complex tunnels and systems. A town can be thousands of animals, or it can be just a few. Within the towns live smaller groups called coteries, and a group of females who stay together for life, and they're young, live in these coteries. And 1 to 3 males may change, and the females can mate with multiple different males, from what I understand. They live in very arid places because they get their water from seeds and insects that they eat, and it's believed that they mow grasses to keep them short for ease of predator vigilance. That's super cool. That's something I'd like to look into more. It's okay to say I don't know.
Yeah.
And we're like, we're gonna investigate that.
You may be scared to, but I don't know is a perfectly legitimate answer, or I don't know, I'll get back to you on that.
Yeah.
So don't
Or
be
you can
afraid.
encourage your students to research.
Exactly.
See what you can find out.
Yeah, I think walks like that allow for, like you said, a lot of like just kind of storytelling and developing those like personal connections, being like, oh man, I remember when I was a kid, I used to, and you draw those connections, and students can be like, oh, I went on a hike last year with my class, and they're drawing on those personal experiences and, you know, just basically boosting the memory bank and refreshing ideas and being like, oh, this is new, but it reminds me of. So, you know, developing those connections, I think there's so many opportunities for that out here.
One of the things some of us have been talking this week about, you know, we get caught up on the drive for standardized testing, and I have to cover this material, and for me that's kind of a red flag when we say we have to cover something, because that doesn't equate to learning. And I love the idea of taking the time to do something like a nature walk, because you have to just slow down and it's not rushed, and like that's worth the time you're investing in doing that, to let them just explore and use their senses and draw and ask questions and not always be so frantic and like advocating for that. I think that's really important, getting outside. So
think the temperature one for me, like next year I'm doing earth science / environmental with the climate. That's our first project is climate, so obviously that one felt really relevant to do, and to talk about sampling and like how to build out sampling and bias, and I think that could still apply there. I'm still like thinking about the other ones to connect to. I think kids get engaged when you talk about these like bigger animal species. They get interested in that, but I'm still like trying to piece that part together in my head. I'm sure it can be done, but like what they could measure that would feel like it would lead to climate information might be a little difficult in the quarter class. But definitely the temperature one for me was.
I looked at this, the second hobo I had down where we were doing the temperature stuff, and I compared the two, and just in the middle of the day it was so much cooler down there by the water than up with the trees where we usually would meet on the trail. The rest of the day it was about the same, but just in the middle of the day it kept cool down there. So, and I don't know for sure if it's just how much shade there is or how much the water. It's just being in the water keeps things cool. So there's more questions that you could test that, distance from the water and see how far, what the temperature is, some distance from the water. So there's lots of things.
The science, maybe this isn't the exact science we'd be teaching, but seeing how it relates to that. Because I mean, like,
cross-cutting concepts.
Yeah. Because like in 6th grade they do force and tectonic plates and stuff like that. So it's not doesn't lend itself 100% to what we were doing, but the collecting the data part, I think, totally connects to math, and that's exactly what I would want to do. Is I'm like, let's go outside and let's just see how many dandelions are in like this 10-foot area, and then so if we have this many in this 10-foot area, how many do you think we would have in a 100-foot area? So so that way they can see how scientists work. Yeah. So this is how we work. This is how the numbers work.
Yeah, I felt like a sponge this week. I'm not yet a teacher, but just hearing everybody's perspective. I was saying to Scott earlier, it seemed like when we were all in our designated groups, everybody was willing to bring to the table their idea, and there wasn't like, okay, well, you probably know more about this. What do you think we should do? It was like a lot of sharing, and then hearing everybody talk about, oh, this would be great. I could take this back to my school and do the, take it to the schoolyard, study the grass around the school, study the flowers, just so to be able to extrapolate ideas, what the concepts, what we're working on out here, and take it, like what you said, like taking things from a large scale to a small scale, make it tangible for the kids so that it's not this daunting thing. It's been cool to hear everybody talk about, like, oh man, in my class we've been doing this, so I could be able to, take these, classifications of flowers, and we could look at, the classification of whatever different types of grasses around the school. Those types of ideas where, not everybody's gonna be able to come out here all the time.
Right.
But that wasn't the point, to be able to be like, hey, you have to get your students out here. No, like take what we did out here, bring that to your school, figure out how that's gonna work. Like, there's cross-cutting ideas of data collection, like math and science. That's about as deep as you're gonna get on a cross-cutting concept right there. You can, you're two birds, one stone right there.
The reason why you learn math and the reason why you learn science, there's more to it than just
the relevance
Not
as well.
that multiplication test, right?
It's not, I can do the standard algorithm and I can do it within like 2 seconds.
Yeah.
Okay, that's great, but why are you doing it? Why are you computing these things? You want to know the reasoning behind it.
Exactly.
Answer, and it's at the back of the book or whatever. But real science is nothing like that, and so to give them that better sense of that, and again, whether they go into science or not, those are beneficial skills to like the problem solving.
And it's like, whoa, that's science. Like, that's what science is. Like, you just